Hi, third grade. I hope you're well. So I've been speaking with Paula, and as we finished Partial 1, and we've now a couple of weeks into Partial 2, I've been talking about her about what you're doing, and she said you were doing separating mixtures. So I thought we would look into that and maybe get a bit more technical and how to calculate the different concentrations of mixtures. So let's go. So today we're going to look at concentration and how to calculate concentration. Now, there are three ways to calculate concentration. What we're going to do today with grams per liters or solute over solvent, I will explain more. Another method of concentration is percentage concentration. And finally, one called parts per million. So maybe the next three or so classes will seem like they have quite a bit of mathematics, but it is chemistry, but using a lot of maths in the chemistry, but not this kind of concentration. So before we begin, I think it's important that we look at these four words because we see them all the time in chemistry, but do we actually know what they mean and how they are different? Okay, so let's go over them. We'll start with atom. So an atom is the most basic unit of matter. Okay, try to, I don't know, look at the table in front of you and think what is the smallest unit that that table is made out of. If you made it as small as possible, that smallest unit would be the atom. Okay, so an example obviously would be sodium. One atom of sodium has 11 protons, it has 11 electrons, and it has 12 neutrons. Okay, and you can see those electrons there, excuse me. So how is that different to element? Well, they are similar, a little bit different. An element is a substance where all the atoms are the same. So this is sodium metal, okay? So this piece of metal is actually made of billions and trillions of atoms, okay? So there are billions and trillions of these atoms inside this sodium metal, okay? So the atom is the most basic unit, and an element is a substance where all the atoms are the same, okay? Next is compound. Now, compound and mixture is when you get more than one atom mixing, okay? So a compound is two or more atoms from different elements, very important, different elements which chemically combine, okay? So the classic example is salt, okay? So salt, which you have on your tacos, this is a compound because we have an atom of sodium here, sodium is Na, and an atom of chlorine, and they actually connect to each other, okay? And when they connect to each other, they make a new compound, and that's called sodium chloride. It's different to sodium and chlorine, because obviously when you're eating food, you're not putting a block of metal on your chips, are you? You're putting something different on there. So you've got sodium and chlorine, they react and they form a new product, and this is a compound. So where two or more atoms from different elements chemically combine. Finally, a mixture, which is kind of what we're looking at today with concentration. So a mixture is a physical combination of two or more substances. There is no chemical connection, no chemical reaction. They're just two different entities together, okay? So an example can be seawater, okay? Seawater has salts, but it also has water, okay? And the salt dissolves, but the salt doesn't change. It doesn't turn into something new. Neither does the water, okay? So seawater is a mixture of water and salt. So what we're looking at today is a solution, and a solution is a homogeneous mixture. Homogeneous, you might have seen that with Paula, maybe not. If not, we can look at it ourselves. But homogeneous means that the salt dissolves in the water, and the water is liquid, but if you let the water evaporate, the salt would be remaining. Now, a solution is the salt and the water. So this ocean water, this sea water, that is a solution because you've got salt and you've got water, two different compounds. Now, this salt and this water have special names. So the salt, which is the solid, we call the solute. And then the water is a solvent, which would be the liquid, okay? And the solute will always dissolve in the solvent. And then the solvent and solute together makes a solution, okay? So lots of S's. Solute plus solvent equals solution. So seawater is a mixture of many things, but let's just say it's salt and water. The salt, sodium chloride, is the solute. The water, H2O, is the solvent. And then the solution is solute and solvent. So seawater, which is salt and water, is the solution. So what we want to do is we want to calculate the concentration of a solution. Let's look at this jar of water and salt. How much salt is in the water? This can be really important in chemistry when we're always trying to make some reactions. We need to know what are the quantities of each part, okay? So 8 grams of salt is dissolved in 250 milliliters of water. What is the concentration in grams per liter? And this is our first way to measure concentration, grams per liter, okay? G/L, okay? So to calculate the concentration, we take the solute in grams and divide it by the solvent in liters. It's very important that the solute is always first, then divide, then the solvent in liters, and that will tell you your concentration. So if we look here, 8 divided by 0.25. Why have I done 0.25? Because here the question asked you 250 milliliters, however you need liters. And when we're doing concentration in this method, we always want grams and liters. So if you've got kilograms or milliliters, you need to convert them. 250 milliliters of water is 0.25 liters, okay? So 8 divided by 0.25 is 32 grams per liter, okay? 32 G/L. So these are the questions that I would like you to do today. For question 1 and 2, maybe you need to do a little bit of an investigation. Salt is a compound. I want you to try and find another compound and write the name. And then salt water is a mixture. I want you to find the name of another mixture, okay? If you have any troubles finding one, send me a message, I can help. But I'm sure with a little bit of investigation on the internet, you can find some and you realize there are many, many compounds and mixtures in your house, in your room right now, probably. And then finally, question 3, 4, and 5 are some concentration questions. For 3 and 4, you've got to find the concentration. However, for number 5, you have the concentration. You need to calculate the grams. Guys, that is the end of our video on concentration. Like I said, this is going to be a trilogy, you might say, a Star Wars, a Lord of the Rings on concentration. So I'll see you next time where we will continue and look at a new way to measure concentration. Please answer in a Google Docs and upload it to Classroom, and I look forward to it. I'll be online for the hour if you have any questions. Guys, have a nice day, and I will see you next time. Bye-bye.